Okay, before going toward the demo, I would like to highlight the challenges related to two things. First is single node model, and the second is ML practices. So this session cover two type of challenges. First, related to the single node. Single node mean a scikit model or any model which is not distributive in a nature. And the second thing is ML practices. ML practices mean covering end-to-end life cycle like data to deployment and other like CI/CD as well. So second aspect will be covered by the Sagemaker API. So let's start the challenges associated with the single node model. Single node model is not scalable. By scalable mean you cannot do training on a large data set, especially when the data set is in terabyte of size or maybe in petabyte. So it is not suggested to go for a single node model, because if you try to do, your model will gonna be explode due to the lack of memory. Second is training time. Training time is very high when you're trying to do a single node model to train on a chunk of data. In that matter, you may able to do a training for large data set, but you ended up in losing a lot of time on a training. Third is resource intensity. Resource intensity mean if you want to fit a large model on a large data set, you may have to require a huge VM, which may require like more than 100 gigabyte of RAM, because in RAM it is not just a model, there are data and other serialization, deserialization process going on as well. So this is why a huge hardware is required in order to do a single node model for a large data set. But in real world cases, this is not possible. We may not bear a cost associated with the large model. You may heard about the large language model, and the cost associated with that, it is so huge. You may ended up in bearing a cost on hundred of thousands of dollars. So this is not a suggested way to go for a single node model for a big data set. There are a number of other challenges as well, but I highlighted the main pain point for the single node model, and I will try to explain how Spark ML tackle all these challenges. Second challenges is related to the ML practices. By ML practices mean covering the ML workflow, like once you train the model, you may have trained number of models. You have to pick the best one, but you are not interested to lose the track of all experiments. You are interested in comparing different model with each other and pick a best one based on some matrices which you decided with the business team. And then once you pick that model, you want to go to the production environment. But keeping track of experiment is not an easy when you're working in if you are working in a simple laptop or some environment where tracking is not possible. So you have to manually keep track, and you may not use it efficiently. So the second is collaboration. Collaboration is an important aspect when you're working in an ML team. So in an ML team, you have to collaborate at code level when you are developing the model. You have to collaborate at development and deployment staging. So in all stages, you have to collaborate with each other. So if there's a good collaborations, you may develop a good model, and your productions environment is robust to tackle all the real life traffic. That is model deployment. So although it is not a task of machine learning engineer, but in today era, we are looking for a one-man army who can do each and everything in ML. So when ML engineer have to deploy a model, he may have to create an API. For API mean exposing your machine learning model to global, so that world can access your model, create prediction, or generate some inferencing. And the last is inference. So inferencing at scale is an important aspect, particularly in production environment. So when we are developing a model and when we are testing, we do not consider much about the traffic, like what is the flow of traffic and how we are going to deal with such flow of traffic. So if you deploy it on your created server, like you may deploy your machine learning model on your GPU cluster on your local machine, but you have to take care of traffic. So if that's the case, you may ended up losing a huge set of traffic. So if you deploy it on some cloud environment, so cloud environment is capable enough of scaling those traffic, and cloud environment is responsible for managing all the inferencing and related stuff. So enough of those challenges. So what are the solution? Regarding the challenges associated with the machine learning model, particularly single node, so Spark ML is the solution. Spark ML works in the same way in which Spark work, like in distributed, it first map the function, then reduce it. Similarly, it is computing the machine learning model in this way, first mapping it on a multiple worker node and then reducing and calculate a result and generate a single model, and then single model is going to generate a prediction for you. It is distributive in a nature. This is why it is scaled for a large data set, and it is it training cost is less as compared to the single node model. So training time is reduced because of the distributed nature when your worker node is working in a parallel fashions, and each worker node is computing on some chunk of data. So at the end, these multiple worker node can compute or fit on different chunk of data set, then combining those informations and generate those informations and hand it over to the driver node. So in this way, you may end it up in reduced training time as compared to the single node model. Spark ecosystem. Once you are in a domain where you have to deal with the big data set, so you are not just limited to the machine learning workflow, but you have to take care of data pipeline as well. So for the data pipeline, Spark is the de facto standard, which is the choice to go for by the data engineers in a real world cases. So Spark ecosystem work perfect for the Spark ML. You can integrate Spark ML with your Spark job, and you can if you have a good grip on the airflow, you can orchestrate data engineering pipeline in Spark with the data in machine learning pipeline in Spark ML integrated with using airflow, and you can generate end-to-end data and AI workflow. So Spark MLlib is optimized for iterative algorithms. By iterative algorithm means Spark train the machine learning algorithm in iterative fashions, and these iterative machine learning model distributed across the worker node, and it is optimized in terms of memory, and it is optimized in terms of I input and output overhead. So Spark ML in short, it will deal all the problem associated with a large data set, and if you have to do ML on large data set. Second challenges is related to the ML practices. For ML practices, in this demo, we are going to use Sagemaker API. Sagemaker is a fully managed machine learning platform that cover all the aspect and that allow you to develop machine learning model and deploy in a serverless way and in a scaled way. So it offer you to do elastic scaling. So if you are conscious about cost, you may go for elastic scaling. So it will scale up, and if there is a high traffic, it will automatically scale down for hours in which there is a normal flow of traffic. Okay. So SageMaker facilitate collaboration on different stages. While developing model, it allow you to work in a notebook, and you can collaborate model development using by sharing the notebook, or even different developer can use the notebook cell in a parallel way to develop the model. And similarly, when you are like once you develop a model, so entire team can see that model, test that everyone can test that model using the endpoint you created. And once it is good, your team can decide upon a particular machine learning model and deploy it by using a few lines of code. So development and deployment in Spark is in SageMaker is easy. So SageMaker, the flow of SageMaker is you create a model, create a Docker, and then deploy a Docker image. So this is a flow. And in SageMaker, you can use the pre-built Docker, or you can create your own Docker image and push it to the ECR repository. If you are good in the with the Docker environment, it is your choice. If you believe that your custom model is good enough, and Spark pre-built model does not cover a lot of aspect which you need to cover, you can create your custom model and create a Docker image and push to the ECR repository, and then this ECR repository can provide your model on the endpoint, and in this way you can easily create an endpoint. So due to SageMaker use the Docker extensively, so it is easy for SageMaker to scale up and scale down your model, because the Docker container is easily scalable. You can just create an image in a matter of second, and all those SageMaker or Docker container, once spinned up, they can start generate inference for you. Okay, let's dive deeper into the architecture. So architecture for this demo is simple. We are just using two major services from SageMaker, from AWS, sorry. First is S3 and the second is SageMaker. So these two services are enough for us for this demo. S3 is for storage purpose. We can use S3 to store our data, and we can use S3 to store our model artifact. And the second is SageMaker. SageMaker is for model development till the model deployment. So SageMaker almost cover all the aspect of ML workflow, so we don't have to worry about extra services. But in real life cases, when you have to deal with the big data set, so your data engineering team may suggest to create a data pipeline on AWS Glue, but in if you created a data pipeline on Glue, it is still easy to integrate Glue with the SageMaker. You don't have to worry about the roles. You don't have to worry about the credentials. All these can be managed by the AWS Secret Manager. You can just plug the Glue with the SageMaker, read the data using the Glue, and then in iterative way or incremental way, you can train your model and deploy it using the SageMaker. Okay. About this architecture, this is a simple architecture. This architecture is divided into three phases. First is data acquisitions and processing phase, where we are working with data like cleansing, wrangling stuff, and organizing in a Spark format. So data acquisition mean we are loading the data from S3, and then data analysis. I did not cover the data analysis in this way due to the shortage of time, but in production environment or in some business scenario, you have to analyze, you have to do EDA, and then it is good for you to pick up the relevant features after the EDA. Then data cleansings, train test split with, and after train test split, we need to convert data to the SparkML. Unlike scikit model, we cannot feed our numeric data directly to the Spark. So Spark machine learning environment believe on vector implementation. So right, once we created the our feature engine ready data set, then we need to convert those data set into the vectorized form. So Spark will use that vectorized form to do machine learning. So I will later show you how we can convert. It is easy step and it is important. Otherwise, you cannot, your Spark ML model will not run. It will give you error. Second phase is model development phase. So model development is like a typical development life cycle, like create model development notebook, do all the stuff related to the model development, like pulling in SageMaker lingo, pulling a Docker container, train it, and then deploy it. So training job, you can create a training job using multiple way in AWS environment using SageMaker, or you can use some third-party orchestrator like Airflow as well. And right after the training job, you can inference on test data set to check if your model is capable enough of generalizing on new data set. If it is, then you can, after evaluating, you can deploy it. So in this demo, we are evaluating in a single notebook. So all these steps will be covered in a single notebook. So this is the power of SageMaker, or it is depend on you. You can use the .py file, or you can use the SageMaker notebook as well. Just 1 minute. Okay, so the last phase in this architecture is model deployments. In model deployment, we need to first create the deployment configuration. Deployment configuration is artifact file where we are mentioning instance type, like what is the instance type we need to use for inferencing and training purpose. And then we need to specify the instance count, either based on business scenario, you can use 1, 2, or you can use the elastic. All this type of configuration you can mention in the deployment configuration file. So deployment configuration, you can pass a dictionary of deployment configuration, or you can simply pass it in a Docker container when you are creating image. So in this demo, I make it as simple, pass all the deployment configuration using the training and deployment phase. So it is easy. Otherwise, it's depend on you. You can pass the JSON, you can pass the dictionary, whichever suit best, you can go for it. Then create a model container. So this is the point which I focused previously. Um, SageMaker works based on the Docker container. You can create your own Docker container, or you can pull the pre-built Docker container and use it. So almost all there are number of model containers, pre-built model container already there in the SageMaker repository. So it's a rare case. You have to create your own. Like if you're working with the TensorFlow, there is already a pre-built image. For PyTorch. There is also a pre-built image as well. MXNet, and also in this case, SageMaker. There is also a pre-built container for SageMaker as well. After a Docker container, you have to create endpoint. So endpoint is like a single link. This link is associated with the model container. You push a request to this endpoint. This endpoint will request the prediction from Docker container. This will fetch the result for you and then show the model predictions in response. Some REST response, if you're working outside of the AWS environment, you can use this SageMaker API. If you're working inside the SageMaker environment, you can call it using a simple Python function. And all this stuff related to the deployment can be done using the SageMaker PySpark. For the data phase, I use the data acquisitions and data processing for I use this Apache Spark. SparkML lib specifically for model training, and yeah, SageMaker API just for model deployment. So I provided this demo on Medium as well. You can scan this QR code, or you can click on this link to jump to this demo as well. Otherwise, if you want to do it your own, you can pull the GitHub repo in your SageMaker notebook and just it like a plug and play. You don't have to do a lot of code. Let's jump toward the SageMaker notebook. Okay, before starting our demo, I would like to present you the our workflow. Like the first, we need to set up S3. Then after setup, once we set up S3, we need to set up the SageMaker environment. For the SageMaker environment, we need a AWS IAM role, and this IAM role is responsible for managing all the authentication between the AWS services. And then third, we can run our notebook, create model, create training job, create endpoints, and that's all the workflow. So before jumping to the notebook, you have to create S3. Simply type S3 here and create S3 bucket. Leave all configuration to default. Don't change anything, just simple click on bucket. And yeah, one thing, select the your like preferred location. So I usually prefer US West 2, as there are a lot of services available in that region. You can go the region of your choice. Then leave all the options as default and click create bucket. Just simple. I am hearing some echo. Sorry, my voice was echoing. Okay. Second is create a SageMaker. So before creating a SageMaker, we need to, okay. So creating a SageMaker is simple, but the one tricky part is the IAM role. So IAM, during the creation of IAM role, if you go for the default from the Amazon SageMaker, so you may have to read little bit of documentation like what are the services you are required and what are the action for those services required during the SageMaker process. So you can click it, or otherwise you can manually create your own. So I manually created my own IAM role. So creating IAM role is simple. Type IAM here and click on not user, click on roles. Inside role, these are all the roles I have created, but creating a role is not a big deal. Pick it like you have to create for the SageMaker. Pick the SageMaker, click on next, and click all the relevant policies which are required. So if you are new to the AWS and you are working in isolate environment, so you can go for checking all the policies, all the actions from the SageMaker, although it is not suggested. Always go for precise policies, but if you are new, you don't know much about the policies, you can go for it. And one interesting thing in SageMaker is once you created your role, you can simulate it. By simulation mean you can check either a particular action have access for this role or not. So it is a simple and interesting thing. How can you simulate it? After creation of role, you can select your role. I'm selecting SageMaker role. This is the role I created for SageMaker. So in a nutshell, you need two type of access or policies for SageMaker. First is for S3 and second is SageMaker. For SageMaker, your role should have access for creating notebook instances and creating a Python notebook or all the notebook, and should have access to the ECR and SageMaker pipeline, S3 Studio, SageMaker Studio, and number of other. You can read the documentation, but for this demo, I created role which have all access to the SageMaker. So let's check how can we simulate the particular service access. So let's assume for this role, I want to check either my role have access to S3 or not. I can select the S3 here, and in select action, best is to select all. So this will select all the S3 action for you, and just you can run simulation by clicking it here. In a matter of second, it will show you for which action this role have access or not. Please mute your microphone, otherwise my voice is keep on echoing. Okay. Okay. Similarly, you can check for SageMaker as well. So let's check for the SageMaker. So all these are actions in SageMaker. Select all, run simulation, and boom, we have access to all the actions in SageMaker. This is a simple and easy way to simulate your IAM role to check either you have access to relevant actions or not. Jump back to SageMaker. Now it's time to create a notebook instance. So notebook instance is a compute machine where we are doing all the development step. So for this purpose, we need to create a notebook instance. So notebook instance is also a simple name your notebook instance and make sure Your region is same where you created the S3 bucket just to reduce the latency. And then here you have to pick up the role. You can create a new role using the Sagemaker, or you can simply pick up the one which you created. So I pick up the one which I created, and then inside a Git repo, you have to specify a GitHub repository. So if you are running it a first time, you have to click this option, clone a public Git repository to this notebook instance. Provide your GitHub URL here, and this will ask you two things. First is your GitHub name, and the second is you have to specify the GitHub token. Don't specify password, although it is mentioned password here, but GitHub will not authenticate you in case you provided the password here. So the best is to create GitHub token, provide it here, and right after clicking the OK, it will create AWS secrets for you where it store the your username and your token for the GitHub. So next time, if you want to create your notebook again, you can see your GitHub repo here. Click the create notebook and your notebook will be created. For first time, it will took around 1 to 5 minutes. You have to be patient. And as I already created and my notebook instance is running, so I'm directly jumping to this notebook. Okay, before jumping this notebook, Jupyter Lab is you can use the Jupyter Lab as well, but it is good if you are working in some collaborative way, like you need to commit it, you need to push some, you need to do some git flow work. So then in this way, for this scenario, you can use the Jupyter Lab. Otherwise, if you have to work on simple single notebook, then you can use the Jupyter notebook. This is a simple. And right after creating all the development script in the notebook, you can come back here, open the Jupyter Lab and do the Git workflow there. Okay, so this is the Sage SparkML SageMaker notebook, and this is the single notebook which do all the data till the deployment step. And this notebook is provided here in this in this GitHub repo. It's single notebook. You can clone it and you can directly use it here. So first you need to import all the relevant packages, and these packages are related. The Boto is related to the SageMaker, and it will act as a client for our S3 bucket. SageMaker for doing the ML practices stuff, like deployment and creating model configurations. So for that, we can use SageMaker. SageMaker PySpark. From this API, we can import the pre-built container, and this is the pre-built container from the SageMaker, particularly for the PySpark. Otherwise, you can create a custom uh, PySpark container, push it to the ECR, and then import using the ECR repo here. And then the execution role for providing the access between the for the different services inside AWS infrastructure. Spark ML for machine learning, for doing machine learning stuff inside Spark ML, and PySpark SQL for doing data engineering stuff. So first we need to build a connection. Building a connection is simple. Inside AWS infrastructure, create a Boto3 client for S3, and then create call the connections here. Like here, Boto3 sessions region name, it will provide the region. And in the next, you have to get the role. We need to specify this role in deployment configurations. So it will automatically use by the SageMaker API and do all the necessary stuff. We don't have to worry about it. This is why I use the I get the role here. And the jars, all these jars are necessary for specifically for doing the say PySpark stuff. So if you did not use these jars, you may ended up in some error. So all these rest these codes are for building a connection with a Spark. So if you know this Spark, so Spark work in two way, in a client mode and in a cluster. So here we are specifying in a cluster, and in cluster mode you can specify a driver or number of worker nodes, and this can be automatically done by the Spark. So I put it on Spark, so it will create automatically for us. So once we completed the S3 connections, we build the Spark configurations, context. Next is to read a data. So reading a data is simply as we read in a Spark environment, Spark using the Spark Reader API. Specify option for CSV. Here I just specify the simple. My CSV is simple. One thing I forgot to tell you, after creating a S3 bucket, create a data folder inside S3 bucket and then upload your train.csv file. So train.csv file is from the Kaggle spaceship Titanic dataset, which is a simple dataset and the fancy name for the Titanic dataset. And in this dataset, we have to classify either a person can make his trip to a particular planet or not. Simple dataset. So this code will read the data from the Spark and Spark limit dot 5 to show the Spark data. I specified the limit here, otherwise it will pull up all the data. I just need to check the what is the form of data and what are the columns. So limiting this data set is a good way to save your memory, particularly your heap memory. Then check min and max of numeric. So this notebook cell is specifically for saying the negative values for numeric column. And this will give you hint about if there is any negative values or not. So like for the max age, you can see here the max age is, I think this is some other thing. Yeah. So for the max VRDEC 998 and VRDEC 0, so you can see either your values are between some distributions or not. Then the second step is identify missing values. In this dataset, there are two type of missing values. One where specified null, and the second, which is the null. Null is the default, which can be easily identified by the Spark. So for the none, you have to explicitly specify, and this none is for the string columns. Okay, I iterate over all these column and then simply check either it contain none or null, and then apply a count function. So this count function is from the PySpark SQL or data frame API, and it will give you the hint for all the negative values, or not, sorry, not negative, missing values in your data set. So here inside our data set, there are a lot of missing value for home, planet, cryosleep, cabin, destinations, age, VIP, and all those other columns. Transported is our label or our target variable in that demo. How we can remove missing values? Simply by calling a drop any functions, and I specify any. So in real life cases, you have to impute the missing values, and imputing a missing value decided based upon the meeting with the businesses and with the collaborating with your team. So for this demo purpose, I make it simple, deleted any values in any column. If there is a null values in a single column, and for all other columns there are not null values, in that case it will also delete all these row because I specified any. So you can use all. In all cases it will check if there is a missing values in all column, then it will delete, otherwise it will simply ignore and leave the missing value as it is. So I drop the missing values from this subset, then cast this with column to int and to this to room service to integer as well, and then later I check it. So at that step there is not any missing value, and you can again show display your data set here. Okay, the next thing is structurized data. So by structurizing mean, we did not specify the schema during the reading phase. So good practices is to use your provided schema while reading this CSV. But in that approach, there is one challenge. If your one column contain different type of values, for example, there is a column which may create a values in string, integer, or boolean. In that case, your code will crash. So for this purpose, I read all the columns as a string, and then I am converting explicitly according to my Spark format. So I converted all these values to double. You can convert it into the integer or float based on your use case. Or so I, for this demo purpose, I simply convert or cast all those values in a double. Try sleep, age, and if you can compare the previous schema with recent schema, you can see here crash sleep is now double. Previously it was string. Cabin is a string. It is a, yeah, we don't have to worry about this. Age is integer because we changed the age previously. VIP double here, VIP previously string. So this is how you can cast it in Spark environment, or you can okay, so specifying a schema, you can specify schema using two ways, either using the SQL approach or either using the struct. So struct is like data type specific for the Spark environment, which struct is little bit difficult way as compared to the SQL way. So in SQL way, you can just specify a column data type and provide as a string to your uh, spark.read functions schema. Okay, I drop the extra column. I drop extra column. Please elaborate a schema. So a schema, I schema, I mean at this step, you can provide your schema here. Schema for CSV, and this schema will be like here. In a simple cases, like name, string, then age, integer. In this way, you can create a schema, then provide the schema here. But I did not provide the schema here. The best practice is to always inference, provide the schema at the reading time and deal with all the edge cases which may occur during the reading. Okay, where I left. Identify. Okay, structurized data. Now drop extra column. I drop two columns. The first is cabin and the second is the name. For the name, this doesn't make a sense. Unless you are using some LLM, you may get some information from name. But for the cabin, I'm going to convert all my categorical column into one hot column. So the cardinality for this cabin is very high. It contains more than 100 or maybe 1,000 of unique values. So if I convert this cabin into one hot encoding, so I may ended up in 1,000 of features which is useless. So this is why I drop. And you can also get the hint about this when you are performing EDA. At the EDA, you may get the hint either this feature is good for your model or not. Then come the train test split parts. Train test split part is simple. Call the random split function, specify the ratio for training and testing dataset. For this demo, we are dividing 80% of dataset for training and 20% for testing. So random split function is available in Spark, I think 1.13 and above. So if you're working with a Spark 1, you cannot use this. In latest Spark 3, this function is available. You can call this random split, specify ratio, and seed for reproducibility. So when you are doing the experiment later, so seed will make sure you will this will reproduce the same data set which you produce in a first go. Okay, converting data to Spark required format. If you see here, it's our print schema function print the schema for this, and it contain various column, and these columns are not in Spark required format. So Spark is expecting a vectorized feature. So vectorized feature mean all these features should be provided in a vector to Spark. If you're working in a scikit, you may directly give this to your model after converting into the numeric, but for Spark, you need to vectorize it. So in a nutshell, Spark expect two column. One is the feature in vector form. Second is the label. And in the label, I think the best is to use the double. Yeah, double type is good if you use for it labels, particularly for the classification. Handling categorical column. So converting your string column to one hot encoding is a matter of multiple steps. Unlike scikit, you cannot just call estimator, fit, and transform for this Spark. First you have to convert text data into string indexer. So string indexer is like a label indexer in a scikit. You can give the label index directly to the Spark model, but it will not help model, and it will may introduce noise for your model. So once your string or text is converted into the string indexer, then you can use the one hot encoder to convert into the string indexer. So why I'm doing all this extra stuff? Spark works based on lazy evaluation. So I cannot directly provide the column name and call the fit and transform function. Instead, I have to provide the column name, and then later on, when I call the action, then Spark will convert all these feature into one hot encoder. This is why I have to specify first my string indexer column. String indexer column means string to numeric. And then I also need to specify one hot encoder or one hot output columns and to Spark as well. So here I am calling the fit, and the clean SDF is my data set so far, which have not missing value, which is in a proper structure. I first fit my string indexer, and then I fit my SI model dot transform. This will convert into the train SDF. This may looks tricky in a first go, but once you are working and you are comfortable with the SageMaker, then this step will not be like overwhelming for you. But for say SparkML, it is a limitations. You have to work in this way. And similarly, you can call the one hot encoder estimator, provide the input column. So here the input column is this index output column, the output from the string indexer, and the output column will be this, which contain all the uh, column with the suffix underscore OHE. Call the fit functions on train SDF, and then transform it by calling the OHE model dot transform. Provide the train SDF. At this point, train SDF contain all this index output column, all this OHE output column, and then you can this will work. Otherwise, if for example, I did not specify this OHE, this will not work. This is expecting you need to specify all the columns. And then later on, or during the evaluation, if the column name is there during this transformation, during this fit and transformation step, then it will work. Otherwise, it will give you error, and the error will like there is not any column with the name blah blah. Similarly, we need to convert the numeric column, but for the numeric column, we need to vectorize it. So for the numeric column, we don't have to do anything extra, just remove the label column, specify all the numeric column here. In assembler input, combine numeric column with the categorical or one hot encoded column. So all this column will be provided to the vector assembler, and this vector assembler will convert the feature into vectorized form. So if you and the flow of this vector assembler is similar, call this vector assembler. And if you can note one thing here, you don't have to call fit here. Why you don't have to call fit? Because vector is just transforming to one data type like features into vector. Vector assembler does not need to fit on your dataset. String indexer and one hot encoder required to fit call, but vector assembler doesn't need a fit call. It simply required a transformation call, and in a one go, it will convert all the features into vectorized. So how this vectorized features look like? If I show you few example, I think chain SDF. Okay, okay. I think I need to run all this notebook. Otherwise, yeah, my kernel was shut down. This is why this is, but I think it will take time for to save our time. I can show you here how it will look like. Where is the train test split clean SDF drop convert? Okay, sorry for this. Think I specify here. Yeah, here. So for example, this is the feature like 103. So how Spark will convert into the vector? It will generate this vectorized record for this one feature record. So how you're going to interpret it? The first theory is the length of the vector, and the second is uh, 0. Uh, at what index there is a 0? So in this example, there the 0 is at the second index. So here the Spark is using the index from 1. It is for the readable, but behind the scenes Spark work on the 0 index. And 1, 3 is all these values except 0. And this in this way, if you have a data set with huge number of cardinal features or with huge number of set of feature, it will save space and it will be faster as compared to the other implementation. So this is how this form of vectorized feature is called a sparse vector feature vector in Spark ML lingo. Okay, till this point, we are good with the data set. Now we have to create our machine learning model. So as I mentioned previously, creating machine learning model is simple. Here I am calling a Sagemaker estimator class, and this class is behind the scene is a Docker. And how it is a Docker container. Sagemaker role for the Sagemaker role, a role which I get initially, instance type ML M4 X large, instance count is 1, and endpoint instance count. So I'm doing the training on this instance. And after, if I'm lucky enough to that my training job runs successfully, then this endpoint will be created for me. And this is the type of inference. So this is the this particularly these two things are the endpoint configuration, which you can provide during the creation of your training job, or otherwise you can later create, you can provide later on. You can provide using the UI, you can provide it using the Python SDK as well, and you can directly call the function here for endpoint configuration in Spark in SageMaker environment as well. This is the set number on parameter for the XGBoost estimator, and then call a fit. So fitting and transforming is simply like scikit. First call the fit to fit the model on your data set, and the output of this code will be multiple things. First is the Docker ready container for your endpoint. The second is training job. Third is model endpoint configurations, and the fourth is model weight file. So where you can see all these artifact. Oh, I need to reload it again. My bad. Sorry for this delay. It happened. Okay, you can go to SageMaker environment. Inside the SageMaker, there are multiple sections, and to see the training job, you can go to training job here, and there are multiple job with the job status completed and failed. So this is the latest job, and inside this job, if you see the history, so it started prepare the instance for training. So preparing the instance is creating a Docker image behind the scene, downloading the input data to that Docker image, start the training image. Once it is completed, then it will upload the generated training model. Where it will upload the model, you can check here inside the inference models. This is the model created by training job, and this is the location of your S3 where it stored the model. Okay, meanwhile it is loading the S3. I will show you the endpoint configuration. This is the endpoint configuration, and this endpoint configuration is particularly for inferencing. Okay, it's loaded. So yeah, here you can see the model.tar.gz file. This is the model weight file, and this weight file will be used by model configurations, and this model configuration will create endpoint. And yeah, here you can see this is the model configuration instance type I specified the initial count. So I make it, I did not make a serverless, so you can create a serverless as well and apply to endpoint. So it will create endpoint. And where is my endpoint? Here is my endpoint. So this endpoint is in service. You will build on hourly basis for this endpoint. So make sure your endpoint is running when you are when it is required. Otherwise, you can manually stop it, or you can call a stop from the SageMaker API. This is the model container log. If you want to debug the traffic inside your model Docker container, you can go to this. This is the invocation endpoint for my model. This is if you want, if you're calling this outside of AWS infrastructure, then you can use this API and provide the um, feature into JSON form. So once you push the request on the server side, you have to create a script, and inside our script, you have to convert Spark JSON into the Spark required vectorized form. This is the one step you have to do, and you can specify in the Docker script and push it to the Docker container. And you can see the amount of utilizations for the CPU of your endpoint. You can create your endpoint as well. If you have endpoint configuration, then you can provide the endpoint name here. Endpoint configuration. You can see here it already showing the endpoint configuration. This is the same endpoint configuration which is created by the training job. You can select it, and you can after providing the name, and you can create endpoint. And if you see here, you can create a new endpoint configuration as well. So in new endpoint configuration, you can select the serverless. You can check the provision, and for this you have to specify the instance configuration. For here, Okay, moving back to SageMaker notebook. After once we are done with the model training, for this it hardly took around 4 to 5 minutes. Again, as we transformed our training data set into the Spark vectorized feature ready format, similarly we need to do the same step for the test data set. Simply call the vector assembler dot transform. Okay. At this point, why we did not mention all these steps for the testing, we don't need to specify because we just simply need to specify, yeah, we just need to call the transform functions from the string indexer, which we already created for the training dataset, because this string indexer already fitted on train dataset. So we don't have to fit it again for the test. If you do it, you may lose some information from the training. So it is good to always fit your transformer on a big chunk of dataset, then transform it on a training and on the testing in this way. So for example, there is a record which is in the training but not in the testing. You fit on the training data set, but this record is not in the testing, you may lose information. Same vice versa, if there is a record in a test set but the record is not in the training data set, and you transform and you fit on the training data set, you call the fit on the test. So in this way, it will not work because the record which is in the test, not in the training, will not be converted into the vectorized. So best is to fit on the big chunk, then do the transformations on the splitted data set like training and test. Similarly, I fitted on the this data set here, clean STF, and then I'm just calling the transformation function. At this point, my feature for is converted into the vectorized form, which is mandatory for the Spark ML. So here you can see now I have two columns. First is the label and the second is the vector. So predictions, predicting Spark ML in a SageMaker is a simple call a transform function. Unlike scikit, you cannot call a predict because how Spark treating a model is a data transformation function, which transform data set like to one dimension to an other dimensions. So this is how a Spark treated prediction as a transformation step. This is why it is a transform. And in scikit, it is a predict, but it is the choice of developer for the Spark ML. So they mention the transform function. It will convert into this data set. It show you the label, the feature, and the probabilities of the predictions. And right after the prediction, we have to call the evaluation. So for the evaluation, there is a limitation in the Spark ML, and the one limitation is that for the binary classification, there are limited evaluator. Only two evaluator I found out yet. The one is the ROC, area under ROC, and area under the precision recall curve. You can create your own, like if you are good with the Spark, you can convert these probabilities based on your threshold to 1 or 0 form, and then you can create accuracy function which can give you the accuracy of your test data set. But unfortunately inside Spark ML there is not any functions. I don't know why they don't have created, but there are number of other evaluation functions for the multiple label classification, but for the binding they just provided the two. So for the evaluator, we have to first create the binary classification evaluator, and at this step we need to provide two things. First is the prediction column. The prediction column is this one, raw prediction column. Prediction, it will automatically convert the your probabilities into the required labels or predictions like in 1 or 0 form, and then compared it. And label call is this label. Make sure your prediction column contain or contain these two column. Otherwise, it will give you error. So here this evaluator shows area under the curve is 0.88, which is not bad. So um, more you're closer to one, the more your model is able to distinguish between the positive and the negative class. So more you are toward the zero, so it means your model is not capable enough of predicting or classifying the one positive or negative class. So if your data set is imbalanced, then I will suggest you to go for this area under precision recall curve. And based on your matrix evaluation, you can decide upon particular threshold, like which threshold is good for imbalanced data set. Okay, we are at the end of these sessions, and yeah, I can understand it is long, so we cannot cover a lot of things. So I covered a basic for SparkML, and these basic are sufficient for you to work with the SparkML on SageMaker. So as we are proceeding toward the end, so I will like to request from all the audience to go to there, provide the feedbacks, and because based on this feedback, AWS community will arrange future events for you. Yeah, always provide the feedback. Now it's time for QA. Thank you for bearing me this, for bearing me so long. Yeah. Now it's time for question and answering. If anyone have any questions regarding this Spark, regarding the SageMaker, you are welcome to ask. Akasim, welcome to the session.
Hello. Hello. I just joined the session. Sorry for all the disturbance because I didn't know that in my area there will be an internet issue due to Muharram. But I faced a lot of issues today just before the session, and I was just joining, and there was again the problem. I just left off, and then I just again joined. So right now it's just stable. Thank you for all this session and handling this all at your own. I would like anyone, if you have any question, kindly drop down in the comment section as well. And if you have any question, you can unmute
I
yourself
was on
and
mute.
speak up.
There is a questions. Can you train deep learning model also using Spark ML? No. Training a deep learning model using Spark ML is very tricky. Why it is a tricky? Spark ML cannot do a distributive training for the TensorFlow or for the PyTorch on its own. Spark ML will use a Horvath library for distributing a deep learning model on different worker node, and then Horvath library will be used to compute the weightage or learning from all those worker node and combine in a single. So you cannot directly call deep learning models using Spark ML. You need to do little bit of work, and yeah, you have to use Harvard library.
I
I
think
think I'm
Ubaid
clear.
Mujahid is also there.
Yeah. It's if I name it correctly, it's this library Harvard. Actually, the deep learning for big data set is tricky. This is why you have to do multiple steps. So maybe developers are keep on working, and in future they may come up with a minimalistic approach. Yeah, Faizan, we can share. I can, if Kasim, do you have resources like basic or beginner
Yes, I have.
resources?
Uh, Actually, AWS has given the lab format. You can search for SageMaker Studio Lab, and there are some labs available for free. And apart from that, SageMaker Studio Lab is also available as a simulator where you can prepare and you can get to know about how to use SageMaker and how to do all those stuffs because it was not practically on AWS, but you can do all those testing on AWS SageMaker Lab. You can just search that out and you will get to know from there. Apart from that, you can just create your account and do some hands-on on the SageMaker as well. Apart from that, AWS have some resources like AWS skill builders. You can join the skill builder over there. There are tons of courses, but you can search down on the courses related to SageMaker and you can learn from there as well. Let me put that the link of SageMaker Studio as well.
Thanks, Kasim, for such a brief answer. Yeah, any more questions?
Okay, labs are usually paid, but from the SageMaker Studio Lab, you can perform this as a simulator. You can initially request this, and whenever the AWS will give you access, you can perform these all labs as a like tutorial or as a free path. But for specifically on AWS, when you will be using SageMaker, you have to give credit, and it will be paid for you.
Kasim, is there any free tier for SageMaker? Is there any you can
SageMaker, yes,
also
I let me
send?
check this out in the free tier as well. How much free tier we have for the
I
SageMaker?
think there is a free tier for SageMaker with limited capability, but this free tier is enough for basics experiment.
Yes, you will be having 250 hours on the MLT3 medium, and you will similarly have some of the hours available. I can say that it's ranging from 250 to 750 depending upon what you are using, like data wrangler, feature store, training. But you can check this out as a free because it free tier is SageMaker is also available as a free in the free tier. You can just check this out. Yes, I had shared the link of GitHub as well. You can take this GitHub notebook from there, and you can just play around. Apart from that, we will upload this recording as well, and we will send this recording to you as well. Let me reshare the link as well. Here is it. Hopefully, by the end of today, I will upload the video recording on the YouTube, and we'll send the link from the thank you form while giving you access to the link as well. Okay. Someone is writing again. Can we get a picture of CC symbol like this? Danya, can you please correct your camera so we will take some snapshot as well?
Yes, sir, it's fine now.
Okay, okay. Can we make the C symbol like Cloud Club symbol? It's bit invisible, but let me
Yes.
take this out.
Okay.
Okay, thank you everyone. I had taken us one screenshot. We'll put this in remarks on the social media as well that we had a session.
Yeah, before ending this session, I would like to pay my gratitude to the AWS community and especially Kasim for organizing such an awesome event. And yeah, you can reach me out after this session as well. If anyone have queries, you can ask me on LinkedIn. I think I provided the LinkedIn in the GitHub repo. So you can, if you have any queries, you can ask from there as well. So thank you, Kasim, and AWS community for organizing such an awesome event.
Okay. Apart from that, I had shared the GitHub their LinkedIn profile as well. You can just check this out. Okay.